walk you through another transformational proof. This one I find every time I do it, I start to wonder, could I explain that more? Do I need to break it down smaller? These were things that I think we always felt about proofs, is how minute the details have to be. Is it okay if a student calls it a linear pair and then moves on? Do they have to break it down that because it's a linear pair, then there's supplements and so on? Or a right angle brings about the 90 and the 90 brings about the, those kinds of things. Or can we allow a little bit of leap of logic? Anyways, you'll see as I prove this theorem, every time I do it, I do it a little bit differently, and I want to think about more about how well to write it out. But anyways, the classic proof of three angles adding up to 180 is well known. The auxiliary line, the alternate interior, is very simple. I'm about to show you a technique using a transformational approach to this, and really it's the same logical arguments. What I'm going to do in the proof is translate this triangle by vector AB. And what that will do is land the new triangle right in here. And the argument I'm going to present is that by translating along that ray, you form a straight angle, AB, B prime. And that straight angle is made up of three angles, these three. Now if I can establish that those three angles add up to, or equal to 1, 2, and 3, then I can say 1, 2, and 3 are indeed equal to 180. So a few things I'm going to say in this proof is I'm going to talk about how these lines have to be parallel based off of the characteristic of pre-image and image are always parallel after a translation. Also, that translation, as I've already said, creates that 180-degree angle, that straight angle. And that same translation will take angle 1 and basically make it equal to its image, B prime, B, C. These have to be equal, pre-image and image, because of the isometric nature. The only thing left really to say is that angle 3 has to equal this angle C prime B C prime C, because of the alternate interior angles have to be equal. And using a little substitution, 1, 2, and 3 add up to 180. A very similar style proof, but it is based off of the relationship of a translation. There are other ways to do this. You can do a little rotation in here. You could actually do 3 rotations to form this same setup. If you start with a triangle and you rotate it here about its midpoint, and then if you rotated it again about its midpoint, you would find that the angles actually, think about what would happen here. Angle 3 would land in here. Let's see, let me get this right, 2 and 1. When I rotate it here, you'd get 1, 2, and 3. Look who all lined up, 1, 2, and 3. There's another way to do it using a transformational approach, as a couple of rotations. Anyways, let me write it down for you and kind of show you how logically I'd lay it out. It isn't perfect, but it gives you an idea of how to structure the logic.
Provide us with some examples of proof using transformations that maybe we normally do differently. The classic proof that the sum of three angles adds to 180 is often a proof based off an auxiliary line and some alternate interiors. I want to use a transformation to do that. And the idea I want to do is use a translation, and it will create some nice environments. Ultimately, the logic, though, is very similar to the classic proof. So I'd like to start by doing a translation of triangle ABC by vector, let's see here, AB, creates the following. So this motion is going to provide me a number of things. So B prime again is here, A prime will be here, C prime will be somewhere here. Now what I want to do is I want to list out the things that this translation provides for me. It creates the following. 1, a straight angle A, B, B prime by extending side AB. So I know that this has to be 180 degrees. So that's one of the things that it provides. I'm going to do point form this time. The next thing it also creates is AC is parallel. AC is parallel to BC prime because pre-image and image are parallel after translation, part of its definition. So I'm kind of listing what this translation's doing for me. It created a nice 180 degree straight angle there. It created some nice parallel lines here. It also tells me that the measure of angle 1 down here would actually have to equal to the measure of B prime, BC prime, because of its isometric nature, which we know that if you translate the pre-image, just like what I said up here about the pre-image and image, the pre-image and the image have to be equal when we're all said and done. So you can see I'm starting to evolve my idea here. I've got a 180 degree angle. I'm going to be able to say that angle 1 matches this, angle 2 is already there. And now I want to make one more move to talk about angle 3 in there. The other thing maybe I should have mentioned is that straight angle A, B, B prime. I created it. Well, let's do it now. Straight angle A, B, B prime is made of the measure of angle 2 plus the measure of angle C prime BC plus the measure of angle B prime BC prime equaling 180 degrees. The measure of angle 3 is equal to the measure of angle C prime BC, this angle. These are equal because alternate interior angles are congruent with parallel lines. So I've now got this basically alternate interior. The very last stage is I've done all the hard work. I've established that it's 180 degrees. I've established that angle 1 has to be the same as that angle. 3 has to be the same as that angle. So I'm going to make 2 substitutions. I'm going to pop out these angles, and I'm going to drop in our angles. So the measure of angle 2, now this angle C prime BC, I just said that that's equal to 3 because of the alternate interior. This angle here I earlier established is the same as angle 1 because of the isometric nature. And so therefore they all equal 180 by 2 substitutions. And we can rearrange this and make it the same, but I think the idea is there. So this is an interesting approach. Yes, a little more writing, but the logic is still there, right? It's just a matter of expressing the logic. So by extending that side, I made a straight angle. That straight angle is made up of the 3 angles that are there. And then I showed how the isometric translation maps this to this, how it created parallel lines that allows me to say alternate interior, and then 1, 2, and 3 add up to 180. A nice little proof.